Hello everyone, I'm Jason Sykes, aka the Tech Rancher, and this is my homework solution for lesson number 38. This is based off the course called Raspberry Pi Pico W, which is performed by Paul McWhorter. He does multiple electronic engineering videos. You can find him on YouTube at Paul McWhorter or on his website at www.toptechboy.com. And let him know I sent you. That would mean a lot to me if you could. Alright, let's get this going. Let's put the thinking cap on because today we're going to be doing a video for the homework solution about trigonometry. Alright, I know a lot of people probably just clicked off and said, oh boy, here we go, math. Well, Paul did a really good job showing an example of trigonometry. He made it very easy for us to be able to understand trigonometry, and one of the foundations that he talked about was that trigonometry is based off circles and not triangles. We use triangles to be able to plot the arc around a circle. Once again, foundation circle. So let's dive in this and kind of regurgitate what Paul had already did a video on, and let's just see if I can help that out a little bit better. Alright, we're going to learn about sine, cosine, and tangent of a circle. First, we need to know what a sine, cosine, and a tangent is. You can see over here beside, on one part of my screen, is a circle. And inside the circle, we put the x and y axis in here. And inside the middle of the x and y axis is the origin, which is right in the center of the circle. So everything on the right and left of this line, horizontal line, is part of the x-axis. Everything up and down that intersects the origin is the y-axis. It's vertical. The numbers around the circle, we're going to get to that in a little bit. Right now, we just need to focus on the x and y because that's what we're going to be using. If we draw a line that goes from the origin and intersects the arc of the circle on the outside, that would be our radius line. This is going to be the beginning of our inside triangles to be able to figure out what an x and y or sine and cosine is. As you can see what I wrote here already, that x would equal cosine and y equals sine. Let's dive into this and get a better understanding of what this is. Let's go ahead and say that we're given a radius that goes up to the 60 degree. It could actually continue on past the arc, but we're only concerned about where the line of the that we had come from the origin straight up, that we're going to call the radius, intersects the arc at a 60 degree angle. So our theta is 60 degrees from the origin up to that. If we draw a line, it comes down from where it intersects the arc down to the x axis, and if we put a little dot, which I did not on my drawing, but if we put a little dot right there, this line that we just drew would be the x this would be our y vector. And then from an origin over to where that dot, which I did not put in, but it intersects the x axis, that would be our x vector, which we actually can say the cosine and then the sine. Now we want to be able to plot where our x and y coordinates on this arc is. Well, there's a formula that we're going to use to be able to do that, and I'm going to use the Pico W REPL to be able to type into to help you out. I'm repositioning my notes here so I can see a little bit better. First of all, what we need to know is that our radius is not depending on our circle, because we don't care right now about our circle size. So we're saying radius, as we said on this chart here, or on the circle chart, radius equals 1 because we don't really care about the size of our circle. With that said, we can eliminate out of our formulas that we're going to do right now the radius. But if you have any circle that you need to know what the actual radius or the circumference of the circle is, you need to include the radius in this formula. So the formula that we're going to look at without the radius, because we're not worried about the size of our circle, and therefore we're saying radius is 1, is cosine. This is for the x-axis, and we're going to open our parentheses and we're going to do the degree, and that we're wanting divided by 360 times 2 pi, and then we close it. Now I can't run that because it's not correct for the MicroPython. It will give me a syntax error, but I just wanted to be able to show you right here. Let me get that out of the way. I just kind of wanted to show you what that formula is. Now that's for our x. This would equal our x coordinates. So that would equal our x coordinate. But now we want to know what the y coordinate is. So this is pretty much the same, which would be sine, because that's going to be our y. And then we're going to say degree, REE, divided by 360 times 2 pi. And that would equal our y coordinate. Now, let's put this in practice. Now we saw what our x and y coordinate formulas are. Let's put it into practice. Oh, by the way, before we do that, if you need to be able to determine, if you're needing to determine your circumference of your circle, and therefore your radius has to be involved with it, it would be actually a ray, r for be radiant, ray times, and then due to x will be cosine, and once again degree divided by 360 times 2 pi. That's what it would be for your x if you need to determine the size of your circle. If you can think back and remember our videos that we did for homework lesson, and I'm not for sure which one, but we did a floating potato chip. In that La Joule type of thing that we did include the radius because we wanted to manipulate it and we want to make it larger. That was a flashback, but anyway, now let's put this in practice now, since we looked at those two and saw all about that. We want to know what our x and y coordinates, and so let's use an example of that 60 that we have. So we know the 60 degrees already, so we're going to do math because we're actually going to run this cosine, and we're saying 60 degrees divided by 360 times 2 times math.pi. And this is going, oh, I didn't type in pi right. Let's try that again. It got me confused. All right, is 0.5. Well, you can see I already have it written up here on this little display, little thing that I did, which is 0.5. And so what does that mean? What's 0.5? Well, since we are saying that the radiant is equal to 1, or the radius is equal to 1, half of that radiant from the origin out to this arc is going to be the same from this origin to this arc line. So we're going to say half of that is right here. Now we wanted to go and figure up upward, so we went over 0.5 of the total length, which is total 1, so we went over 0.5, and so we put a little dot. Now we need to figure out how to get up here. So now let's do that math formula. So it's math.sine, and once again it's 60 divided by 360 times 2 times math.pi, and make sure I add the I this time. And that's 0.866. So we're going to roughly around at 8.6 is what I did on that chart. So we're going to go up 0.86. Not quite 1, but almost. And so that's going to be our there we go. We plotted our first plot on our arc. And now we have a dot on our arc. Now let's go in there and let's learn about degrees and radians. As you can see on the outside of these, we have the first ones are, this is the radians, and outside of those are degrees. And so instead of this being gibberish, let's learn about it. Okay, so I'm referring back to my notes here, and it says I wrote radian. It's a new word for us in this problem-solving adventure. Radian is a unit of angle measurement, and we say 1 radiant, and the symbol of radiant is rad, so 1 rad is approximately 57.3. I have a chart for this, and let's look at this chart. Haha, there we go. So I have wrote right up here 57.3 degrees times pi divided by 180 times the radius, which we said 1 on this as we're doing on this project, equals 1 rad. I didn't write rad because of the y axis is in the way, but I made a capital R for rad. Equals 1 rad. Pretty neat. What's this big deal about this? I mean, why don't we use degrees? Well, we could, but this actually has a significant purpose for it. 57.29 or 57.3 is the line from here to here. This also equals the line value from the origin to the arc. If we were to take this line and move it and start it from right here at the beginning of our arc and curve it up, it would equal the same, which is almost 60 degrees, which is 57.29. The significance of this is if we continue to go on, and just say this is 60, if we continue to go on, we could use this and say 60, and from 60 we could go over here and we could say 120. Well, let's look at this chart over here. Over here on the left, we can say from 0 to 60 would be 1 radian, and then from 60 to 120 would be 2, and then from 120 and add 60 more would be 180, so that's 3. So if we'd said 3 of those, then the other 3 would equal 6 total, so half of that would be 3, so a half of a circle is pi. So here we are, we're starting to go somewhere with this. So we're saying 3 of those equals a half arc or a half moon, and that would equal a pi. Not 2 pi, which would be 360 degrees, but pi, and it equals 180 degrees. Let's come down here and apply this to the chart that we're looking at, that I have down here, this chart. Let's look at 180 degrees, and you can see that for 180 degrees, we have it reduced down to pi, because it's actually, we're saying 6 over 6 pi. Because we did 1, 2, 3, 4, 5, and it's 6 over 6 pi, and so that would actually be 6 of the 30s, but it would actually only be 3. We're saying if we did 30, I did this in 30s instead of 60s, so that's why I'm going to have to change it here and tell you. This would actually be 3 over 3 pi, because there's 3 of the radian on the half moon. And the other 3 on the other side, from 180 to 0 or 360, would be the other 3, which would be 80, 240, 300, and then 360. So that would be our other 3, but right now, so that would be 3 over 3 pi, which would reduce down to pi. That's the pretty good significance of what the radian is, but it gives you the angle of the arc that we're determining by. So let's start looking at this chart. Let me just get it back up here, and let's look at a 30-degree angle, which is 1/6 pi, which we can reduce that down to pi 6. Now I want to show you that math, how we did that. Let's clear this and start fresh, and let's write this down. So we started out with 30 over 1. Well, that equals pi over 180. Well, we can reduce this, because just take away our 0 first, because we know in the order of division we can do that. So now we have 3 and 3, 1 over, well, I tried to click on it, didn't work. Oops, that didn't work either. This can also equal 3 over 18, which would be actually 3 pi. 3 pi over 18. Well, this can be reduced down, and we can do 18 by 1, and so the 18 goes in by 6, and so we say 1 pi over 6. Well, we can just go ahead and eliminate that 1 and say pi over 6. Now you can see where I got a 30-degree angle over here on my chart. 30 degrees equals pi 6. Well, let's do some more here. We're learning here. Let's do some more. Let's just, oops, sorry. It's getting late tonight where I'm at, and I'm getting kind of silly because it's getting late. I'm sorry. Let's look at a 90-degree angle. All right, so let's type in 90 over 1. This is the same as saying pi over 180. Well, once again, we can reduce or deduct that down, so we can say that, and then we come over here. And it's the same as saying 9 pi over 18. Well, 9 and 18 can be reduced, so we can go ahead and lose the 9 here, which would actually be 1, but we don't need to do 1, and we'd say 2. So we can say pi over 2. And if we look over here at our 90, that's what we got it reduced down to, pi over 2. Now we're getting somewhere. We're starting to learn this. All right. Well, there's another way to do this. Instead of writing pi, we actually want to see base 10 digits. We actually want to see digits here instead of a symbol. So let's show another example. We're going to say 90 times math.pi divided by 180, and that's going to give us 1.570796. What's that? Well, that's the radiant. That's what it is in radiant, and so I can tell you how that is. So let's do math.pi divided by 2. Well, that's it, 1.570796. And I was just kind of showing you how that is. So now let's look at this again. Let's say we want to take a radiant back to the degrees. So we're going to type in 1.570796 times 180 divided by math.pi. And this would give you, which is 89.999, but we can round it up to 90. So that gives you our degree. So there we go. We took a radiant from our chart, our radiant that we knew from on the arc of the circle, and figure out the degree. We went from the degree and figure out the radiant. So we said 90 times pi divided by 180, and we reduced it down that way. Looking at my notes real quick, make sure I'm getting everything that I want to. Yes, okay, now let's look at the other side here. Did we just do that? Yes, we did. Okay, so the homework was actually this chart that you can see over here that I wrote all out. Paul wanted us to be able to show our chart and reduce it down to show the degrees to the radians and the radians to the degrees back and forth. So that's what I did. But I want to continue on a little bit more and talk about some other things that we did. And so let's say that we are given the x and not the y coordinates, and we want to be able to figure out the radiant of the formula to solve the problem. So and to do that, we're going to come back over here and look at the REPL and type this in. So we're going to say math, because this is the function here, math.arc cosine, and it'll be a cosine. And we're going to say, well, we need to determine the x that was given to us. And so what was given to us was negative 0.642, and that gives us a number of 2.2679. Wait, that's the radiant? Yeah, that's the radiant. And I can be able to prove that to get it, it's our radiant. We'll just go ahead and do what we just learned. We're going to take our radiant, 2.2679 times 180 divided by math.pi. And this gives us 129.9, which is 130 degrees. So we have figured out what our radiant is 130 by, they gave us our x coordinate instead of our y. So we figured out that. Now we want to be able to say, we want to solve for a tangent. Now we need to be able to know what a tangent is. What tangent is the slope of our, let's come up here and look at this chart real quick. Tangent is the slope of our radius. So it's from the origin up here to where we're at, which is this one's pointing to 60, but it's our slope. This is our tangent. And so we want to be able to figure out what our tangent is. Well, isn't the slope formula m equals y2 minus y1 over x2 minus x1? Yes, it is. Good. But okay, but we're starting with the ordinate of 0, 0, so we can go ahead and eliminate x1 and y1. And so we can just do y over x. Well, let's do an example here and determine our tangent. And let's see, did I have one here on my notes? Yes, I actually did here. We're going to do math.cosine. Oh, no, sine, because that's our y. And so we're going to just say, whoops, 130 divided by 360. And see, once again, we're figuring out our radiant times math.pi. And then we're going, that's our y, and then we need to divide that by math.cosine, because this is our x. I'm sorry, I'm running out of space here. And I can't move it over. My screen won't let me move it over, but we'll go ahead and continue on. We'll press on. So it's 130 divided by 360 times 2 times math.pi. We'll close up parentheses. See, sorry. Once again, not being able to see had caused a problem. And here we do it S and we enter. Now we got negative. We have negative 1.191754. Well, okay, now that's our slope. We figured out our tangent. And let's take this and let's figure out our radius to be able to do another way to do our slope, to be able to do our tangent formula. So to know what our radiant is, we're going to do math dot, let's go ahead and do the y, sine times 130 divided by 360 times 2 times math.pi, and that gives us a value of 0.7660444. Wow, that's a mouthful. And then now we're going to take that and we're going to say math dot tan, and we're going to add that in there because that's our radiant, 7660444, and we get the same number. No, we did not. Where did I go wrong? Wow, that's embarrassing. Let me figure out what's going on here real quick. Let's see here. Oh, I know what I did wrong. I gave us the y coordinates, and we don't want the y coordinates. What we want is the rad, or the radiant. And so we'll be able to do that. Would take 130 times 180 divided by math.pi. Nope, that's what I was thinking. That's why I paused. It's 130 times math.pi divided by 180, and that is 2.268928, and that's our radiant. It's becoming a long video and I'm messing up, and I apologize, and it's making me laugh. Okay, so here we go. Now we're going to take this and we're going to take math tangent, and then we're going to use that radiant that we just figured out, 8928, and then that is going to give us a negative 1.191754. And if we look up here, that's the same thing we did when we did y divided by x. So that gives our slope. So we can use math.tangent and enter in the radiant, and it gives us the same slope. It's been a long video, and I thank you all for hanging in there as I tried to hit all the points that Paul did and try to regurgitate it. Helps me learn it, but also maybe you guys would learn something too. I did my homework assignment and I did some addition. If anyone has any questions or comments, please leave them below and I'll try my best to get back to them. Until next time, be safe out there, everyone.